So let me go ahead and pull up the game we were working on last time and go ahead and play it just so that we can get a refresher of where we are. So we have our enemy working, coming up, stopping. He attacks us. We can run away. He'll chase us. When we get close, he'll attack again. And all that fun stuff. Okay. That's where we left off last class. And so what we're going to do today, hopefully we'll get to two things. One, I want to show you how to instantiate objects that may have scripts attached to them and how that works. And maybe we can do some attacking or damage associated with attacking. So I can show you how that works as well. Okay. Any special requests that we may or may not want to add to this game that are related to the things that you guys may be working on?
Yeah, this might be a little off topic for movement and such, but I was looking on environment for my game, like making a custom skybox, stuff like that. Maybe some like terrain. Maybe not for this class, but at least the next one, because I'm still looking through that.
Okay. Yeah, skyboxes are pretty simple. They're pretty much just a texture that you drop.
I made one that just looks really wonky, and
Wow.
terrain I still haven't figured out.
I wouldn't necessarily suggest making a skybox unless you're good, but under lighting environment, you just drop the skybox here. There should be lots of free skyboxes available on the Unity Asset Store. So that's always a good place to check those out. And you can even change the color and stuff like that of the skybox and the shadow colors and all that sort of stuff. So that's generally my suggestion, but yeah, we can take a look at environmental stuff after we finish this. That sounds like a good idea. Okay, so here's what we kind of talked about last time. Maybe instead of having our rat show up right away when we run the game, maybe have them show up over time, and so that'll add them every few seconds. We have more rats and we'll instantiate them that way. Mitch, you said, are we going to do any UI for this game? So we did a little bit already with the score and the health bar. Do you mean more than that?
I think the video for speaking of the UI I think the video for that disappeared off the Zoom thingy. Like if you go to Zoom. Oh, it's right there.
Should be right here.
Okay, sorry,
I think you're right. So what I've done is in Zoom, the cloud recordings don't stay, but for I think 30 days. And so I download them and then re-upload them so that they're permanent. There you go. That's that. Okay, and I'll do the same thing for this one, as in a start button. So yeah, a start button's as simple as just going to whatever main GUI that you have, whatever object holds your canvas, and you right click and go UI button, and then that will create a button for you, and then you can assign actions to the button. That's pretty basic as far as that goes. If we have time at the end, I'll show you how to do that just for time's sake. But and the first thing we should do is let's go ahead and get the attack working with health, because I'll show you how one way that we can do that. So when the enemy comes up and he performs his attack animation, nothing happens. Okay. There's no health decrease like we should see. There's no any sort of visual effects. Nothing is actually detecting collision. Okay. And so there's a couple different ways to do this. let me run through those briefly. So you can do a collision-based approach, okay? Collision-based approaches are when he smacks us, we have a collider on his hand. And so what we could do is we could actually go into the rat, go into his rig, which is his bone structure. So we would go spine, and then would put on his right hand, drill all the way down until his right hand. And we could literally add a collider onto his hand, okay? And we would want to shrink this. Okay. Do something like this, essentially. And then what would happen is if the hand collided with the mouse, then we would essentially reference, or we would handle whatever we wanted to there. Okay. We would use on collision enter. And when we would need that to happen, or excuse me, we would use on trigger enter for that to happen. But I'm not a fan of doing it that way. And the reason for that is it relies on actual physical checks for collision. And so if it's really close, but it doesn't hit, it's not going to work. And so if we run this and just kind of see how this works, depending on the animations and the models that you have, this may or may not work. Okay. And so when he goes to smack him, here, it looks like this is colliding just fine. Okay. And so in this situation, we may be okay doing this, but we may not want to use actual collision to do it. We may want to do it based off of animation. Okay. And so another downside to using collision like this is if you have multiple attack animations. Maybe you have a kick animation. Maybe you have an attack animation that uses the left hand or two hands at once, or it's a headbutt or something other than the right hand, where that collider needs to move around and you need to check for it at different times. The third problem with doing it this way is the very first frame that it hits is where the collision is going to occur. And that's not always visually what looks right. So typically with attack animations, the point at which the animation is farthest extended is the point at which you want to see collision. And so, like, let's say we have an attack animation that's like a stab, where you're standing like this and you reach back and then you extend forward. Well, if you happen to be really close to the character, that very first frame where you're reaching back may collide with your target. And so that would trigger the hit, and it would look stupid because you're actually pulling back, but you're still colliding with them. And so it's going to register as a hit, and you don't want it to register until you actually stick forward. And so for all of those reasons, I tend to not use actual collision-based attacks. I don't think they work well. I don't think they often look good. And you can use them. I just think there's a better way to do it. Okay. And others may disagree. It's totally fine. I'm just going to show you what I do. And so instead of using that collider, so I'm going to remove this, we instead are going to use animation-based checks. So let me show you how this works. Okay. So inside of our attack animations, we have our attack animation here. So under our inspector, we're going to go over to animation, and we see the attack animation right here. Okay. What we're going to do is we're going to come down to this very bottom and look at this events section. And in this events section, what we can do is we can trigger function calls to occur at a particular point in the animation, which is very helpful. Okay. So we're right here. He's smacking, and what we want is we want the collision or the hit to occur about right here. Okay, this is what is going to look the best. And so right here, when we get to that point in the animation, I'm going to click right here, add event. And here we can specify a function that we want to be called when this happens. Okay. And then we're going to call check for hit. Okay. And then I'm going to click apply. Now, the way this works is whenever that animation plays, it's automatically going to check for that function on any script that is attached to the character playing that animation. And so when our rat plays that animation, it's going to check any script attached to the rat that contains that function. And so we're going to go inside here. Wait for this to load up. Okay. And I'm going to create a new function. You need to make sure it's public so that it can be called externally, because we're calling it from the animator. Public void check for hit. Okay. And then I'm simply going to print out a message checking for hit. Save and go back. Okay. We run this. And I'm going to pause it. So as we go through, he winds up, goes in, and bang. We see the check for hit that occurred right here on this frame. Okay. So we'll let it play again. It winds up, and watch, the second one's going to occur right, bang, right there. Okay. And that can just repeat over and over. Check for hit, checking for hit. Now, this is also a little bit faster than constantly checking for collision, because when you have a collider on any game object, anytime that collider moves, or anytime anything moves that it can collide with, you have to run the math to see if those positions are overlapping, which can get expensive if you have a ton of colliders in the scene. That's why I prefer this method. Now, we still need to do some sort of validation to make sure it hits, because we can often have situations where maybe our bad guy lines up a hit and we move just like this. We wouldn't want a hit to occur in this position, okay, because we have moved out of the way. And so we simply need to do a distance check when that happens to make sure that the player is in a realistic position to actually be hit. Okay, so let's do that. What I want to do is we essentially need to get some sort of baseline distance. Okay, and so what I'm going to do is I'm going to print out the distance right now every time that check for hit occurs, and then we can kind of manually move the player while the game is running to see kind of what that maximum space is where we should still allow the hit to occur. Okay, so I'm simply going to print out the distance. We'll say distance, we'll say vector3 dot distance trans dot position. Okay, so we are in the bad guy manager script, so we're in our rat script. And so what we are doing is when we say trans dot position, that's the position of the rat, and now we want to get the position of our enemy, which is going to be, or excuse me, of the player, which is going to be stored inside of target. Is this more economical than having a collider on the hand that we would activate, deactivate during the attack animation? So if you're going to activate and deactivate colliders, it's not necessarily more economical. There's a little bit of overhead associated with running the function call from the animator like we're doing. On the other hand, there's a little bit of overhead running the collider approach. I prefer this method. There's nothing wrong with doing the collider approach, and you can activate it, deactivate it, but you're still going to run into the same issues that I mentioned before with the use of a collider. One is that if you are going to turn it on at a specific point in the animation, then you might as well just do this anyways. Two, if you are going to turn it on at the moment that you attack, like right here, like we activate it and then we turn it off after a certain point, then you still get into the issue of potentially colliding with the target at a point in the animation where it wouldn't make sense to trigger an attack. Okay, and so maybe you swing like this, and then as you're coming back, you hit him a second time. That's not what you want. And so then you have to go through the hassle of turning the collider off at a certain point in the animation, or maybe you hit him during like a wind up portion of the attack animation like we talked about. And so there's a lot of issues with using colliders that I just don't like. On top of that, now you have to deal with rigid bodies if you don't want to necessarily deal with rigid bodies. And so you can do it that way. It's just different. I prefer this way. Okay. Say target dot. What is target? Target is a transform. So we just need to do target dot position. Okay. So this is going to give us the distance. Make sure this is not running. Save. Okay, so if player is completely still, we attack, we've got a distance of 0.66. If we're moving, right here, we've got a distance of 0.1. And so let's do it like this. Is he gonna hit me again? Okay, so what I'm gonna do is I've got the game paused. I'm gonna take our mouse and I'm going to move him just a little bit out of the way. So essentially what I'm looking for is kind of like, what is that maximum distance that still looks like he's getting hit? And so this is kind of out of the reach. And so this is 0.95, which is about the maximum that we would want this to go. Okay, and we see here what we want to avoid is making sure that the enemy, if he is out of range of attacking the player, that he doesn't stand there thinking he's close enough and continuing to attack. Okay. So here, let me move him just a little bit. So this actually does hit him. So this is 0.85. 0.83. So it looks like, I think if we go with 0.9, that is kind of what we want. We'll say private float attack range, or we'll say attack hit range equals attack hit range equals 0.9F. Okay, so anything distance wise less than that is going to be a collision. So here we'll say if vector3.distance is less than attack hit range, then we have a successful hit. That's it. Now, if you have multiple attacks, probably need multiple variables for each of the attacks, unless they happen to all be the same, then you can reuse them. Successful hit, successful hit. So we saw him swing there, trying to time the attacks. We're not getting successful hits there. Okay. All right. Any questions on what we've done so far? Okay. Now, go back into this. So on the player manager, we have this change health, right? And so what we'll do here is on the successful hit, we say good game manager dot instance dot player dot change health. And this is where those little comments are helpful. Okay, we did these little 3 block summaries. Because when we do this, it pops up and it says adds the supplied value to the current player cells, pass a negative value to deal damage to the player. So here we're just going to pass in a negative value, we'll just say 0.5 or -5. Okay, so now we can actually run it, and we would hope that we'll actually see this decrease up here in the health bar as the player gets hit. Then we do. Okay. All right. Questions. Okay. Now let's instantiate our bad guys. All right. So I'm going to take this rat and I'm going to make a prefab out of him. So if we're going to instantiate things, instantiating basically allows us to make a copy of an object that exists. It doesn't have to necessarily exist in the scene already, but we're going to create an instance of a prefab that we have marked as a prefab. And the way you create a prefab is simply by dragging and dropping an object into the prefabs folder, and doing that makes it blue. Okay, and then we can go into the prefab, make changes, and it will affect all of the other prefabs that we have made. Okay, but what we want is no rat in the scene, no rat to start with. And then we are going to, on our game manager, make sure we attach the player. Does the player attach himself? Yeah. Okay, so the player attaches himself. So if you ever have a situation where you don't assign a value like this and you want it to be none, you should hide that value from the inspector. So it's just hide in inspector. Okay, that way it won't show up, even though it's a public variable, it won't show up here. And it'll help clean up your code, because you don't want to look at that and say none and be like, oh, I forgot to drag and drop something. If you don't want to drag and drop to assign the reference, just hide it. Okay, but we do want to, we'll say serialized field private, and we'll say game object, and then we'll say bad guy prefab. All right, so serialized field again means it's going to show up here. And what we're going to do is we're going to take that rat prefab that's in our prefab folder, and we're going to drag it and drop it here. Back. Now we've got a rat prefab. So now we can instantiate this rat over and over again, and it's going to show up here. Oh, wrong button. So inside of our game manager, we'll say public void spawn bad guy. So every time we do spawn bad guy, we are going to want to instantiate a bad guy and put him onto our field. Okay, and so we can do a couple different things. We can create spawn points, which can be relatively easy to set up. So you can do just global locations, X, Y. You can actually use objects as spawn points. What do you guys want to do? How do you want to set up? How do you want to tell the game where to spawn the enemies?
Maybe just have like one kind of gate where they all kind of come from.
Okay, I like that idea. So we'll go create plane. So we're going to take this plane, we're going to rotate it like this. 8 goes 0, 0, 0. Put it back here, right on the edge of our environment. Let's go. We'll call this a spine wall. And then inside of the wall, I want to raise this up just a little bit so we don't allow the player to see behind it. We're going to create another plane. And then we're going to make this one smaller. Pull it in just a tiny bit. We need some materials. Create a new material. We'll call this spine wall. And this can be blue. See how this looks. We don't want a collider in this. Why is this not showing up?
Can you add a material to a plane?
Oh, thank you. Like, I'm pretty sure you can do that. All right, we'll make it blue and then we'll have a door. And our bad guys will come through the door. This on the ground. So this will be spawn. And we'll make this black. We don't want it transparent. Okay. All right, and then what we're going to do is we're actually going to spawn the bad guys right on the other side of this door, and we'll have them kind of like run through it. Should probably make this.
Will they fall off the side of the plane though?
Shouldn't, because we're not using gravity.
I mean, oh, I see.
Okay, and so I'm going to create an empty game object, and I'm going to call this spawn point. And I'm going to put it right back here. The reason I'm doing a spawn point is because it's easier to move this than try to work with actual numbers. And so we want to make sure this is, we want to offset that to just like that. Okay, let's try that. Let's just go -1 position. So go back to our game manager. And you could separate all of this code onto a separate game object. If you want to do like a spawn manager or an enemy manager, you could put all of this code on there. We'll keep it simple, just leave it on game manager. It doesn't really matter. But we do need some variables. So we're going to go serialized fields. What I'm going to do is I'll say header. This is just a UI organizing thing. We'll say enemy stuff. So serialized with private transform spawn point. And I think that's it. Okay, so when we want to spawn the bad guy, all that we are going to do is we're going to use the instantiate method. Okay, and you can see there's lots of different things that's overloaded a bunch of ways. All right, and so we are going to spawn, so we want bad guy prefab, and we want to spawn it at a particular position. Now, if you see this as clones the object original and returns the clone, and then you can specify the parent, and that's like if you want to child it to an object when you create it, you can do that. We don't need to do that. We want to keep it on the root level. And so here is what we want: clone the object, and position is the position for the new object. And so we want to spawn it at spawn point dot position. That's what we want to do. Okay. Why didn't it like that? I think it wants a rotation. All right, quaternion dot identity is a rotation that is 0, 0, 0, 0, which just means give it whatever. It's not going to matter because he's going to always turn and face the player as soon as he gets spawned anyways. Okay, so that's what this will do. Now, instantiate does return a reference to the object that we created. And so if we needed to get access to the bad guy's script for whatever reason, we could do that. So, and we would do it like this. So you could say game object new bad guy equals like this. And then you could say new bad guy dot get component bad guy manager, and then set the target like this. Okay, so what this does is it takes that newly created game object, grabs the script attached to it, and then calls a function with it. Okay, we don't need to do anything with it, and the reason we don't is because as soon as we instantiate it, the start function gets called and it automatically sets the target to the player. If for whatever reason we wanted to do different things with our enemy, then we would need to do this here to change whatever parameters or values we wanted to. Okay. So this is going to spawn a bad guy. So when the game first starts, we want to spawn one bad guy. All right, spawn a bad guy to get the game started. Okay, now, before we do that, we need to assign a couple things. So we need to drag and drop our spawn point so that we can access that. And then we need to drag and drop this rat so that we can have something that we want to instantiate. Okay, so let's click play and see what we got going on. Do we have a rat? Nope, we have a null reference. Okay. Now, who can tell me why this happened?
Did we have like that prefab set up in the control thing?
Yes, we did assign that. So if you go to, where's game manager? We've got the rat and the spawn point set. Here's a clue. All right, so Aiden's got it. Awake gets called before start. So inside of awake, we spawn the bad guy, but we don't have the start set up that actually creates the game manager. Okay, and so we want to go to game manager, and we don't want to spawn the bad guy in awake. We want to spawn him in start. Okay. Now we see him coming out of the abyss, and he is walking on the air. So if we go to the rat and see how it says clone, that means we've instantiated it. And he's up in the air. We don't want him up in the air. Okay. And so what we need to do is make sure that spawn point is even with the ground. All right. So if we go to the spawn wall, and the spawn wall is up in the air, we don't really want it up in the air. And so let's move it down a little bit if we need to compensate by extending it higher into the air, we can. Okay, so we'll go 1.25. Spawn point. Let's move this. What spawn point? Let's spawn door. Now let's point this 0.5. And let's go. Okay. Now the spawn point should be at 0, -2. And this is, we're rotated 90 degrees, so all of the axes are off by 1. Okay, so now that we've got it at 0, we should be good. Let's save, run it again, and we have our bad guy coming out of the gates, and he should still be able to attack us, and everything is good. Now we could have it set up a couple different ways. You know, you guys have all played a ton of games, and there's different scenarios for how bad guys spawn. Could be a timing based thing, could be a something that triggers when the user does something, but let's do it simple. And this I'll show you how coroutines work, which can be helpful. Let's do this. So we'll say private. So let's spawn a bad guy for now every 10 seconds. I know that's going to get to be a lot, but it's something that we can easily change in the future. And so what we're going to do essentially is we're going to set up a coroutine, and a coroutine is essentially a function that runs in its own thread and gives us the ability to pause or wait for periods of time and do things at whatever interval that we set. And so we're going to specify an amount of time where we wait in between enemy spawns. Okay, so we'll say private, we're going to use wait 4 seconds, and then we'll say enemy spawn timer. Okay, or enemy spawn delay is probably better. And then inside of awake, when we set all of the things, let's say enemy spawn delay equals, actually, I'm going to do this inside of start. We'll say enemy spawn delay equals new wait 4 seconds, and we'll say every 10 seconds we want this to run. Okay. So all this is this is the variable that will wait 10 seconds, and we can reuse this every time we want that to happen. All right, and so in start, I'm going to now start a coroutine. And a coroutine, like I said, is a function that runs in its own thread. You call them similarly to how you call regular functions, only we do it using the keyword start coroutine. All right, so let's do start coroutine, and then we'll call this spawn bad guys with an S. Okay. And we're actually going to get rid of this initial call. And we'll put an S on this. And when you have let's change this to private. The return type for a coroutine is always I enumerator. And in order to use this, you need to be using Unity Engine collections. System.collection. System. Okay, so this right here starts a coroutine. And this coroutine works just like a function, but it does give us the ability to pause and tell it to wait. Because it's running in a separate thread, it doesn't have to be a part of the main game thread. Okay, now the reason we have this squiggly lines underneath is because we haven't told it to wait. Okay, and that's what all coroutines need. We need to return some sort of enumerator. And so what we're going to do is the very first thing is we're going to say, we don't actually even need to reference that. Okay, we're going to spawn a new bad guy. Actually, I'm going to change the structure a little bit. I still like the idea of public void being able to call this separately from any function. Okay. Run bad guys. So here we'll say yield return enemy spawn delay. Wait 10 seconds, then run the code. Okay. This is essentially what happens. You say yield return enemy spawn delay, and then we will spawn the bad guy. Just like that. That's it. And so what will happen here is this will allow the player to play for 10 seconds before a bad guy shows up. Okay. Now, at the end of that, we will want to call this function again. Okay. And so you can do that a couple of different ways. You can simply put this inside of a loop where it happens over and over again. You can simply call it at the end here. Where we call start coroutine, run bad guy spawn timer. Okay, and that will just simply start the function all over again. Okay, and maybe there's some sort of logic here. Maybe you do it where as long as there aren't a certain number of enemies, then you respawn another one. Okay, there's lots of different things that you can do, but this is one way to set it up. Okay. So this should create a new enemy every 10 seconds. All right, so here's our first one. He's coming out of the gate. There's our second one. There's our third one. Ow. Well, now it's getting a little out of hand. Okay, and this can run forever.
Like an exponential spawn rate. Or would that just break the game?
This would run until we run out of memory, which would be a really long time. Okay. Now, if we had a situation where the player needed to be able to kill the enemies, we would need to keep reference to them. Okay. We're still running at like 500 frames a second, 600 frames a second. I think we're good. Okay. You can see it right here. then we would need to keep track of all of these enemies. And that would be as simple as creating a list that referenced all of them. Okay, and so if we wanted to do that, we would simply come up here to this enemy stuff and we would say private bad guy man. Well, let's do it this way. Private list. Oh, I think we need. This is how we get lists. Private list, bad guy manager. List, enemy list. I guess to be consistent, we should call it bad guy list. All right. So inside of start, we'll say bad guy list equals new list. We'll actually create it here. So we have a list of bad guy managers. So now we can actually keep track of all of the bad guys. So when we spawn them, we're going to instantiate it. This is going to give us reference to the game object. Okay, we know that because when we mouse over instantiate, we see game object right here. This is the return type. So we're going to get access to the game object, but we don't want the game object. We want the script that's attached to it. Okay, and so we're going to say dot get component bad guy manager. Okay, and then we're simply going to say bad guy list dot add what it gets passed. Okay, now if that line of code is too much for you at once, you can break it down. So you can say game object bad guy equals this, and then you can say bad guy script equals bad guy dot get component bad guy manager. Bad guy list dot add bad guy script. Okay, you can take all three of these lines of codes and separate them, or you can just do it all at once here. Okay, one's not necessarily better than the other. It's just whatever you're comfortable reading. Okay, both of these two things do the exact same line of code. This one's just broken out a little bit more. All right, so we'll go. Well, I'll do it like this just for the sake of making things easier. Okay. Spawn a bad guy and add a reference to his script to the list of all bad guys. Okay. So now what we could do is we could say region bad guy bad guy function. Kill all bad. We could kill all the bad guys. And so we can loop through the list or loop through the whole list and kill all the bad guys. All right, so we could say bad guy list at position I dot. I think you should destroy it. I think destroy it. There you go. So this would destroy all of the bad guys. Could you also handle it with tags? In what way? Like destroy everything that has a certain tag? If that's what you mean, you could, I think you can go game object dot find objects with tag and do it that way. Yeah, you could, and then so you could do it like this. And then this would return, if I can type, this would return an array of game objects, and you could do it that way. If you were simply going to destroy them, doing that, that would be fine. But you would have a hard time finding. First of all, game objects.find is really slow. You want to not use that. Simple games like this, it's fine. But the nice thing about the list is we're actually storing references to the bad guy manager script. And so we could, this would allow us to access information on the script rather than the game object itself. Okay. And so what we can do is with these, I don't think we have these set up anymore. I don't think these are working because we have these are working. Let's see. Is this on player manager? On trigger enter. I don't think this was working because we didn't have a rigid body on it. And I know we didn't like the rigid body for a lot of reasons, but actually now it works. Can we just put a rigid body on this thing instead? I don't like rigid body on the mouse. It makes them run funny. Let's see if this works. So you need a rigid body on one of the objects. We need to make this wall, this door wider. There we go. Because he didn't use the door. All right, so I'm going to do the same thing here. We'll add a rigid body to that. And then I just freeze all the positions and don't use gravity. So now he can heal by going in the red one. All right, let's in the green one, just for the sake of doing things other than that. We'll say game manager, nope, game manager instance kill all bad guys. And then let's have this spawn every 2 seconds. Oh, they're coming at me now. It's okay, I'm not scared. Ready for it? Ready for it? It's like, oh no. This is the worst game ever. All right, questions? I need to heal. I wonder if we can out heal the enemies. No. It's too many. I thought mice were supposed to be fast. All right, that's a good stopping point. What questions do you guys have for me?
We gone over the coroutines a lot. I mean, I see those used a lot in like tutorials and such, but I'm not entirely sure how they work.
So coroutines are just like functions. The only difference is you can use them to delay and pause things. Okay. And that's exactly what we do here. Like we allow, so we call run bad guy spawn timer, and then we wait a period of time that we specify. So in this case, we're using 10 seconds. And so this is just a wait for seconds object. And you could do yield return that variable. You could say equals yield return new wait for seconds, and then put a value in here. So this would wait 5 seconds. We just reuse the object in this case, because we want the same amount of time every time. If you wanted like a random delay where return new wait for seconds, you could do like random dot range 5 and 10. So this would wait either a random amount of time between 5 and 10 seconds, and then it would spawn a new bad guy. So that adds an element of randomness to it. This is basically the kind of entry level use of coroutines. You can do more complicated stuff with them. Like you can do things like while a coroutine is running, like wait, you can do something like that. That gets a little bit more complicated, but you shouldn't need that for most basic games. But a lot of times, if you want things to happen at regular intervals, or you want to like start something but not actually complete the task until a certain point, like we want to start the spawning process, but we don't want to spawn until a certain amount of time has passed, you can use it for that. So this allows threaded stuff, and there's lots of good YouTube videos that just cover coroutines at a really basic level and just show you a couple different uses outside of this. I always encourage you to check those out. But
Yeah, I'm
coroutines
definitely gonna watch those over after this.
Yeah, you can do a lot of cool stuff with them. Again, my goal for this class isn't necessarily to go super deep in a lot of areas, but to kind of let you know what's available, so that as needed, you can explore those topics in greater depth. That's the goal.
Thank you.
Welcome. Other questions for me? Okie dokie. All right, well, we will stop here for today. I'll get this video up on Canvas as soon as it finishes.